Assalamualaikum and salam sejahtera. In this session, I'm going to show you how to answer question 5 for individual assignment 2, BT 10403, Statistics for Business and Economics. Question number 5 is related to chapter 11, the chi-square and non-parametric test. A social scientist wants to determine whether the life expectancy of the Malaysian man is independent of their religious affiliation. A sample of 100 Malaysian men aged 90 years and above is surveyed and the results are tabulated as shown below. The life expectancy for over 90 years old, so this is supposed to be 90 years old or older. Religion A 27, religion B 26, religion C 18, and no religion 29. So we have four category 100 Malaysian men, 27 plus 26 plus 18 plus 29. And test to see whether there is sufficient evidence to indicate that the longevity of man is independent on a religious affiliation. Take significance level equal to 5%. So, testing to see whether there is sufficient evidence to indicate that the longevity of man is independent on religious affiliation or not means that we are required to identify whether the population proportion for religion A, B, C, and D are identical or not. Since we have four categories, we divide it by 100. So the population proportion for region A, B, C, and D supposed to be 25% each. So here we have the hypothesis statement, where the hypothesis now states that the population proportion for religion A equal to B equal to C equal to no religion equal to 25%, while hypothesis alternative states that the population proportion for religion A is not equal to B, not equal to C, not equal to no religion, and not equal to 25%. So the hypothesis alternative here states that the population proportion for A, B, C, and no religion are not identical. So question A, what is the critical value of the chi-square? B, what is the degree of freedom? C, what is the value of the test statistics of the chi-square? D, what is the p-value? And E, can we conclude that the life expectancy of the Malaysian man depends on their religious affiliation? State your reason. So in order to help, or in order to show you on how to answer question 5, let us use another example. In this case, we have Finger Lakes Homes. Finger Lakes Homes manufactures 4 models of prefabricated homes: a 2-story colonial, a log cabin, a split level, and an A-frame. To help in production planning, management would like to determine if previous customer purchases indicate that there is a preference in the style selected. So just like in the question 5, in this example, we are also required to determine whether the population proportion for the categories that we have are identical or not. The number of homes sold for each model for 100 sales over the past 2 years is shown below. 30 colonial, 20 log cabin, 35 for split level, and 15 for A-frame. So we have 30 plus 20 plus 35 plus 15 equal to 100. The hypothesis now states that population proportion for the colonial equal to the log cabin equal to a split level and equal to the A-frame equal to 25% each. because 4 categories CLSA divided by 100, we have 25%. Or if I can rephrase it, 100% divided by 4 categories, we have 25% for each categories. The hypothesis alternative states that the population proportion are not equal to 25% each. Not 25% for colonial, and they are not identical to the log cabin, non-identical to the split level, non-identical to the population proportion for the A frame. So the rejection rule, remember that in a chi-square test, we are also required to either reject or fail to reject the hypothesis null. If we reject the hypothesis null, that means we conclude that the hypothesis alternative is true. If we fail to reject the H null, then we cannot conclude that the H alternative is true. So in order to reject the H null, we will reject the H null if the p-value is either equal to or less than 5%. Or we reject the H null if the chi-square is larger than the chi-square critical of 7.815. So we reject the H null when the chi-square statistic is larger than the chi-square critical that is equal to 7.815. So this chi-square critical is obtained by referring to the chi-square critical value or chi-square distribution table. So in order to determine the value for the chi-square critical, we have to know the significance level as well as the degrees of freedom. Remember, based on the example, our significance level is equal to 5%, and the degrees of freedom, on the other hand, is equal to the number of categories minus 1. So we have 4 categories because we have 4 types of homes, and we minus 1, we obtain 3 as the degrees of freedom. So these two informations are important in order to determine, or in order to help us to determine the chi-square critical value. If we can refer to the chi-square distribution table, so this is an example of the chi-square distribution table where the critical value for chi-square will be or can be identified by having 2 key information, as I mentioned before this, the degrees of freedom and the significance level. So our degrees of freedom is equal to k minus 1. 4 minus 1, we have 3, while the significance level, on the other hand, is equal to 5%. Thus, our chi-square critical is equal to 7.815. This is how we obtain the chi-square critical. So we reject the H null when p-value is either equal or smaller than 5%, or we can also reject the H null when the chi-square statistics is larger than the chi-square critical. The expected frequency, on the other hand, is obtained by multiplying the population proportion as stated in the hypothesis null by 100. We multiply the population proportion as stated in the hypothesis null by 100. How do we obtain this 100? Is based on the number of samples that we have. Remember, we have 100 cells. So this is the number of samples based on the question. And based on the question, we also know that the population proportion that is stated in the hypothesis null is equal to 25%. So that is why we multiply the population proportion stated in the null hypothesis by 100 houses or 100 homes. We have 25 for each categories. So the expected frequency for the first category is equal to 25. The expected frequency for the second category is equal to 25. The expected frequency for the third category is equal to 25. And the expected frequency for the fourth category is also equal to 25. So 25 plus 25 plus 25 plus 25, we have 100 homes or 100 sales. So category, what we mentioned by category is the type of houses that we are trying to study. So after we have formed the expected frequency, the next step is to identify the test statistic. See, the test statistic is obtained based on this formula or based on this step. And this step is actually derived from this simplified formula over here. Now let us go back into that calculation. So here, chi-square statistic is equal to 30 minus 25 squared divided by 25. This 30 here is obtained based on the number of sales for the first category. So this is the number of sales for the first category. Our first category is the colonial. Minus 25. This 25 is obtained based on the expected frequency for the first category, the colonial house. Squared divided by 25. So this 25 is also the expected frequency for the first category, the colonial. We repeat the same process in order to include the components for the second, third, and fourth categories. The reason why we include square is because we wanted to eliminate the negative sign. For example, here we have in the fourth category 15 minus 25. If we did not include the squared, then we will obtain a negative value. So here 25 is also obtained from the expected frequency, but for the second category. 25, this component is also obtained from the second category. And that explanation is similar for the third and the fourth categories as well. So 1 plus 1 plus 4 plus 4 equal to 10. So this 10 is the chi-square statistics. So our chi-square test statistic is equal to 10. After we have obtained the chi-square statistic, we can already make our conclusion. And the conclusion can be made either based on the p-value approach or based on the critical value approach. In order to determine or to make conclusion by using the p-value approach, of course, we have to identify our p-value. And in order to identify the p-value, we need to identify two information. Information number one is our chi-square test statistic. Information number two, our degrees of freedom. So our chi-square test statistic is equal to 10, while our degrees of freedom is equal to 3. We have 4 categories minus 1. We have 3 degrees of freedom. if you look into this chi-square distribution table, in the second row, we can identify or we can tell that chi-square test statistic is located between 9.348 to 11.345. So chi-square test statistic, which is equal to 10, is located between 9 and 11. So it means that the p-value, if you can refer to the first row in this table, the p-value is between 2.5% to 1%. Our p-value is between 2.5% to 1%. Or to be exact, our p-value is less than 2.5% and it is larger than 1%. It's between 2.5% to 1%. We also know that the significance level based on the test is equal to 5% if we can refer back to the original question. So this is our significance level, 5%. And we also know that our p-value is between 2.5 to 1%. Thus, we can say that p-value is smaller to the significance level. Our p-value is smaller than 5%. Since our p-value is smaller than 5%, we can reject the null hypothesis. We can already reject the null hypothesis and conclude that the alternative hypothesis is true, where the alternative hypothesis states that the population proportion are not equal across the categories. When the population proportion are not equal, it means that the previous customer has certain preferences in the style of home selected. It means that previous customer has certain preferences in the style of home selected. Apart from using the apart from using the chi-square distribution table, we can also estimate the actual value for the chi-square test using online calculator. If you look into Google, there are various online calculator that can help you to determine the p-value based on certain chi-square test statistic with certain degrees of freedom. So the second method that we can use to make a conclusion is based on the critical value approach. So comparing the critical value with the statistical value is quite straightforward because we know that our chi-square statistical value is equal to 10. And we also have identified the chi-square critical, 7.815. Since chi-square statistic is larger than the chi-square critical, we can reject the hypothesis null and concludes that the hypothesis alternative is true. So here we reject at the 5% level of significance that the assumption that there is no home style preference. In other words, we reject the hypothesis null, where the assumption made is that there is no home style preference at 5% significance level. So that is how we answer question 5 in the individual assignment 2.